So one strong or one basic testing is directed testing. Traditionally, how this directed testing happens is when you have this hardware specification, you plan verification plan using the list of tests, all the tests, list all the tests and plan some verification plan. And we write some stimulus vectors as I said previously, stimulate these stimulate the DUT using these vectors, all these stimulus vectors, and manually reviewing resulting logs and waveforms. This is straightforward. This is age old or like very beginning kind of testing, directed testing. It also produces almost immediate results since little infrastructure is needed when you are guiding the creation of every stimulus vector. So now I'll show you certain figure. Like here you can see the time is more when the design like to approach to 100% coverage, it is taking more time. The basic idea here is as your design complexity is increasing, the time consumed to achieve a good coverage in directed testing also increases exponentially, I would say. Let's say you have tried to verify every combination of inputs of a 32-bit adder. So your stimulus would still be running years after the project should have shipped. Like it is still running. That is very brute force kind of thing. Directed testing is all about having a brute force kind of approach. So if you see this approach, when you have overall design space, you have certain features in it, and you write certain tests, and you might encounter bugs in a feature. So you need to rectify all these bugs in the feature. Like you need to write a test to cover all these features and find the bugs. This is simple in directed testing. So we have methodology basics. Like we follow certain methodologies, as I previously also mentioned this. Like these are constraint random stimulus, functional coverage, layered test bench using transactors, common test bench for all the test case, specific code kept separate from the test bench. Like all these things were related. Let's say random stimulus is crucial for exercising complex designs. A directed test finds the bugs you expected to be in the design, whereas a random test can finds a bug which you might not anticipate in the whole of this testing. Furthermore, once you start automatically generated stimuli, you need an automated way to predict the results as well. Generally, a scoreboard or reference model is a key in that case. Building the test bench infrastructure, including self prediction, takes a significant amount of work, I would say. A layered test bench helps in that case. Like what is layered test bench, we'll be seeing. With appropriate planning, you can build a common test bench for all the tests, which can be used in many cases. And code specific to a single test must be kept separate from the test bench to prevent it from complicating the infrastructure. These are some of the things. And if you observe that here random tests have initially some delay, but the achieving of coverage happens very quickly in random test when compared to this directed test. Like you can see here, every random test you create shares the common test bench, as opposed to what we have seen in directed test, where each is written from scratch. In directed test, everything is written from scratch. Each random test contains a few dozens of lines of code to constrain stimulus in a certain direction and cause any desired exceptions, such as creating a protocol violation, etc. These results is that your single constrained random test bench is now finding bugs faster than what you expected with the directed ones. Like in directed ones, what you have to do is you have to write everything from scratch, whereas in random thing you can use the things that already existing. These we will be seeing when once we go into hands on, like how this thing happen in reality actually.